Welcome to Densify Talks. Oh, thank you so much for joining us. We really appreciate it. My name is Brian. I am the producer of the show. And today on Densify Talks, we welcome Luke Travers, FinOps specialist and principal cloud architect at a major South Korean e-commerce company. Andrew and Luke will be discussing an array of topics surrounding building a culture of continuous cloud optimization. And a little bit about our guest, Luke Travers. With over 14 years of experience in IT and 7 years focused on cloud technologies, Luke is an accomplished FinOps specialist and principal cloud architect. Hailing from Australia and currently residing in Seoul, Korea, his journey has provided him with a deep understanding of global markets. His passion lies in optimizing cloud costs, fortifying cloud infrastructure, and driving business growth. With a proven track record in cloud FinOps, he takes pride in delivering tangible cost optimization opportunities. There will be quite a bit discussed today, and we hope you enjoy this insightful episode of Densify Talks as we unpack the intricacies of cloud computing, optimization, and the evolving landscape of containers and serverless architecture. Here's your host, CTO, and co-founder of Densify, Andrew Hillier.
Okay, thanks, Brian, and thanks, everyone, for joining us today. Today, I'm joined by Luke Travers. Luke, please tell us a bit about yourself.
I'm a ex-AWS engineer, originally from Melbourne, Australia, but now I reside in South Korea.
Tell us a bit about that transition before we get into the topic. How did that come about?
I think like a lot of people, when COVID rolled around, I did a bit of a stock take. And during that process, a South Korean company reached out to me and asked if I'd be interested in trying something new and moving to Seoul. At first, I was not exactly enthused, but I warmed up to the idea pretty quickly. Peak pandemic moved over, which in itself was quite an experience.
That would be a huge adjustment. Things like the language, the food. Do you speak Korean and do you enjoy the food there?
At first, I spoke absolutely no Korean. I very quickly learned how to do the bare necessities, mostly ordering coffee. At first, I didn't have enough Korean language skills to order food, and with the pandemic and the masks, it made things a lot harder. I actually ended up eating a lot of convenience store sandwiches. As a total weird side effect of all that, I ended up becoming a little bit famous online for reviewing the strange sandwiches that are available in South Korea from convenience stores.
That's hilarious. It'd almost be like reviewing 7-Eleven hot dogs in North America or something. It's a convenience store sandwiches. Well, but exactly. I expect they're probably pretty good over there. I'm sure they're very good.
Some of them are a little stranger. It was always a bit of Russian roulette. My most memorable sandwich was a mixture of potato salad, egg salad, crab, strawberry jam, ham and cheese. It's known as an idol sandwich. It's an acquired taste.
I'm sure if you love it, you probably really love it once you have an acquired taste. Let's get on with the topic. We're going to talk about cloud optimization, cloud cost optimization. You've got a pretty extensive background. We were chatting about all the things you've done, Linux background, Unix, even AS400s. And then at some point you started working for Amazon. Tell us a bit about how that came about.
I was working in the automotive manufacturing industry, looking after the Unix and AS400 boxes that manage the factories where a lot of parts are actually manufactured. One morning, I was going to work at, I think most of my shifts started around 3 a.m. I got a LinkedIn email from a recruiter from Amazon, and I thought, oh, that's strange that a bookstore's reaching out to me. And I thought, oh yeah, I'll respond, see what they have to say for themselves. And they ended up flying me up to Sydney for an interview. And at that point, I hadn't actually heard of cloud. And I'm sitting there in the interviews. Someone asks me to explain what cloud is. And I look at them blankly and I mumble out something along the lines of, it's like VMware, right? And their response was a bit of a perplexed look. And they said, I guess. Can you explain how VMware worked? And I was able to explain end to end how VMware worked. Do you actually know what cloud is? I sort of look at them and I'm going to be honest with you and say, no, I actually have no idea. Somehow I ended up getting the job and then spent the next 5.5 years working for AWS. The first year was certainly spent learning what cloud actually was.
What were some of the things you were doing in those 5 years you were there? What were you doing and what kind of perspective did that give you?
I actually wore a number of different hats when I worked for AWS, and I'm very thankful for the ability to do that. I started out in the support team. So as my background's primarily Linux, I was working in Linux support, working with some of their rather large customers. as a Linux specialist, and then progressed through, did a number of different things, and wound up in the professional services division. And from there, I was doing a lot of lift and shift migration. So moving customers from their on-premise data centers up and into the cloud. So there was a number of different programs that were often known as the 30 and 30, 50 and 50, 70 and 70, where we as a team from AWS would go to a company and lift, say, 30 applications and move them to the cloud in 30 days, or 70 apps in 70 days. There were these kickstarting projects to help customers along with their cloud journeys.
And I'm sure in that time you fully rewrote the applications to be completely cloud native and elastic and just run perfectly in the cloud.
Yep, we did all of the optimization work that one can do when you're moving at least one app a day.
Yeah, with lunch breaks. And I think in the early days, everybody was kind of in a scramble to get into the cloud, and that kind of leaves a bit of a trail behind it of issues, as far as things not being cloud native. Post Amazon, what's your focus these days? What drives you now?
What drives me now, you can trace its roots back to those fast-paced mass migrations. After every large migration, you would always think to yourself, yes, it's in the cloud, it's working, but is it what's best long-term? Of course, everything in business it's a trade-off between speed, agility, performance, and efficiency. With these projects, we were heavily leaning on the idea of moving quickly. And I think it was Facebook who coined the term of move fast and break things. We weren't necessarily breaking things, but we were not doing things efficiently. After each of these projects, it left me with this feeling of sitting there thinking, well, what if I'd chosen a different set of instance types for this particular application? Or would this application be better off if we did rewrite it to run only a Lambda? Or a lot of times you'd look at an application, you'd effectively snapshot the machine and then import that snapshot. But a lot of these applications would have been much better natively running as containers rather than on a full fat OS. So now I specialize primarily in optimizing applications that are already running within the cloud.
Mm-hmm. And arguably, even if you're starting from scratch now, people probably don't do a much better job of getting it right as far as what they run on. But definitely if you're migrating, we just see cases where if you're running on-prem servers, you might have batch jobs that run on the same servers. And of course, in the cloud, they don't have to run in the same thing at all. They could be, like you said, a Lambda job or something. So the rapid move into the cloud is one problem. But again, people still, even when they are native in the cloud, not migrating, we find they don't do a much better job of efficiency because sometimes they just don't know what to do. You don't have all the information you need to make the right decision up front. So, and inevitably, I think the big problem this all leads to is, there's performance and there's cost. Avoiding performance problems, people just make things big, and then you have a big cost problem. So let's talk a bit about that, because cost optimization and FinOps really, obviously, huge areas right now. Lots of ways to think about, cost and how to do this, right? What's your view on cost optimization?
If we think back to some of the early days of computers, there was the saying of no one ever got fired for buying IBM. And in the construction industry, no one ever got fired for buying CAT. Doing these large migrations, you can liken it to no one ever got fired for purchasing a too bigger instance, but people do get fired for purchasing too small an instance, their application not performing, and then causing an outage. So it's really important when you think about FinOps and you think about applications running in the cloud, you have to sit on both sides of the fence. You have to look at it from the business's point of view, where they obviously need to serve customers, but they also need to minimize their costs. And on the other side of the fence, you've got the engineers who their goal solely is to have the application running and running stably. And for them, if that requires a 96 core instance, it requires a 96 core instance. And they've probably got sprints backing up and all this work that they need to do to serve new features to customers. And they do a cost benefit analysis, either consciously or subconsciously. Say, do I investigate if this application actually needs a 96 core machine? Or can I run it on something with 20 cores or maybe even just 4? The biggest part of FinOps is building trust with the business to say, I understand your pain, and with the engineers to say, I understand your pain as well. And it's finding that middle ground.
And that's a really good point, because I find, in the FinOps circles, a big topic, and we've discussed it on this podcast as well, is getting engineers to take action. And one of the key observations is that, to your point, they're the ones responsible for the app working. So if you're trying to get them to do something that they don't trust or they don't believe is going to work, or there's any question it's not going to work, it's their job to not do it.
100%.
They're not being obstructive and just wanting to spend more money. It's just, like you said, their head will roll if the app stops working. So when looking at things like cost optimization, our perspective certainly is that you got to be working, first of all, with an infallible answer to act on, because that's the starting point. That's not enough. Like it's necessary, but not sufficient to get it all done.
And where I've certainly seen this fall apart in the past is primarily I use AWS Cloud, and AWS does have some optimization tools built in, but for example, they don't have all the pieces of the puzzle. And so because of that, you are often working with half a deck of cards. The biggest component is, by default, you don't have RAM metrics built in. I know that in some of the previous episodes of your podcast, people have mentioned this problem. If you don't have, say, memory metrics, it's very easy and also totally understandable for engineers to push back and say, no, my application's actually memory bound. I'm not going to downsize. I'm not going to choose a different instance type. One of the key goals is to build up your application reporting tools, your suites of reports to show as many metrics that are useful to the application. I say useful because there's going to be some metrics that aren't useful for all applications. For example, some applications are very clearly disk bound, whereas others are not. So you need to work with each application team to understand each large application, not every application, but the key applications, to see where they're bound, where they're not. Your recommendations are only as good as your reporting tools.
That completeness is so important. Like I almost view it as a giant equation with a lot of terms in it, and you can't miss any of the terms. Like you can't say, what you come up with a recommendation. Well, did you look at quarter end? Oh no, we didn't look. It might use more memory that day. Or did you look at if it's using a disk or the number of, the network configuration? So there's so many things that can make an answer wrong.
Yes.
Just estimating based on a few of them is never enough. What it does is it creates more work for the people to have to go and validate it than it would have been if you never did anything. So totally hear you on that. The completeness of the model is pretty important.
I'm actually really glad that you brought up different time periods. For a lot of, say, the Western world, we're used to big shopping seasons being Christmas and perhaps Father's Day, Mother's Day. And one of the adjustments that I've had to make moving to another country with another culture is understanding that they aren't the same time periods. We have to look at the whole year to understand different traffic patterns, different user interactions. As a side note, one of the pitfalls that can come from doing things such as optimizing storage and optimizing S3 is if you don't have an intimate understanding of when the data is recalled, you can end up spending far more money than you originally tried to save by using the wrong storage tiers if you don't know when data is going to be pulled back. And it's a similar story to scaling. If you scale in too soon because you don't understand your user patterns, you can actually end up costing yourself money or worse.
Contextualizing it is so important. And without going halfway around the world, we see customers, we're just in different industries. Their cycles are so different. Like if you're a logistics company, their peak might be 5 weeks long, over certain holidays, and other companies, it's, quarterly patterns. So those are all, things that go into making sure you have the right answer, which, back to your point, helps you build trust, because you only really need one wrong answer for somebody to say, look, I'm not going to waste my time on this anymore. I'm going to go focus on something else in my day job. So that trust is big. And we think also transparency and showing your work, why you gave that answer is huge.
Yes. You mentioned transparency there. That's actually one of the most key things. Is it's very easy to walk into a room full of engineers and put up a report and says, here's how you can save money. Where that falls apart as an engineer myself, typically they're going to ask questions. They're going to validate that data. And if you do not have this rock solid information to back that up, you're effectively going to get eaten alive and they'll request that you leave the room and leave them alone. So when it comes to building trust, you really do need to, as you said, show you're working. Where does this data come from? Why do we believe this? Because it's often their necks on the line if they make a wrong sizing recommendation for that application.
And conversely, one thing we found, I agree 100%. And what we found is that if the people that are responsible for the apps have input into the decision making, for example, if you say, okay, but let's tune this policy because this app works this way, I trust your data, then there's even higher likelihood that they'll accept the answer. So there's the provenance of the data, and there's also the kind of the path you walk with them to do it together and make sure that you're reflecting things. You know, we've seen lots of cases where that workload's supposed to be idle because it's the backup of something else. And so if you reflect that and then the analytics take that into account, then trust shoots up quite a bit because you're kind of working together on that. So trust and transparency, I mean, we're like-minded there. We think that's huge as well.
A big part of, as you mentioned, is identifying your workloads. One of my old mentors, actually, his motto was your workloads are only as good as your tags. And when I first started working with him, I really didn't understand that. Now, a few years later, I really do start to get that. So one of the problems that happens is if you're in a large company with large departments, large organizations, and you're trying to make sense of what's happening within the cloud, if those workloads are tagged with things such as backup system or hot cold DR, you can then look at that tag, understand that workload a little better before going to those engineering teams and saying, hey, this is over provisioned. When you can then see something like, this is actually the cold backup for if system A falls over, we can then migrate to this, so that when you're presenting to these teams, you can say, we found these look to be over provisioned, but they are our cold backups, they're our warm backups, so we'll leave them alone. And as you mentioned, it's those little interactions that really do help you earn trust.
And it's amazing what a terrible job was done in the early days of cloud. Like, on-prem, there was always a problem with tagging and asset management. You wouldn't know what things were. We migrated to the cloud, and then you would think people would do a better job, but no, it's like there's just, because they're a complete mystery. There could be an instance out there with an obscure name and no tags, and nobody knows anything about it. Like what is that? So I totally agree on the tagging. And again, back to contextualizing. We see cases where somebody might want to say, well, we want a policy that if it's an SAP module, we don't touch the memory, which is important. But you didn't tag it. Like, we don't know it's an SAP module. Like, how do you know what that thing is? Tag hygiene, I've heard that term used, and it's important to get that right, because otherwise everything stems from knowing what on earth that thing is.
Yes.
As people change jobs and staff, change, there's a good chance people won't know what those things are anymore. Tagging is critical.
And without a doubt, the fastest way to lose trust is to make a bad recommendation, such as, this SAP workload, we should really reduce the amount of available RAM. There's no faster way to get your engineering teams offside.
If you want to lose a lot of revenue per minute, just bring the SAP systems down. Let's see what happens. So the other area that I want to talk to you about, because it's kind of similar in that it's possibly even more obscure, is containers. I mean, containers, we see it everywhere. We love containers, but there's more of them. They're more ephemeral and transient, and you can really lose track of what's going on in a container environment. Give me some thoughts on containers, and especially how it relates to cost, because containers can generate a lot of cost in kind of a very indirect way.
Well, perhaps I'm a little bit old school. I fundamentally do not like containers. Yes, I use containers both in my professional and my personal life, somewhat begrudgingly. I think that containers are an excellent solution to some problems. However, I do believe it's a little bit overused. And we do throw things into containers, especially during and after migrations. We throw an application into a container, and then it's pats on the back all around. It's containerized. It's now cloudy, and we're all good to go. You end up with a lot of, for want of a better term, craft, where you have these leftover systems, these leftover libraries, these leftover containers, because you've effectively swept a lot of things under the rug of a container. And if you don't have the ability to surface things like accurate usage metrics and if you don't have good cost attribution and container tagging, again, tagging, as you said, these costs can get lost and you end up with huge clusters with lots and lots of containers, and people don't necessarily know what's in those containers. Is the software in date? Is it out of date? Is it being used, and how well is it being used? Containers themselves are not the problem. It's that it adds that extra layer of abstraction, and if you're not very diligent about it, you can end up in a situation where you've got cloud bills that keep going up and up and up, but if you don't have a way to drill down into that, it can be quite complex. And then when you talk about scaling these containers out, one of the most common conversations I have is with teams where they say, well, this is, you said it's over provisioned, but if I make this change, it's only going to save $100. That's $100 at the container level. But what is often skipped over is there's often tens or perhaps hundreds of these containers on tens or perhaps hundreds of these clusters in one or more AWS regions around the world. One of the biggest things that you have to do is understand that each container has a cost, and you need to track that back. And if you don't, you can end up in a situation where you're having conversations of, yeah, this is only going to save $10, and then you have to effectively steer the conversation to, it's going to save $10, but 1,000 times over. Mm-hmm. Oftentimes, containers make that a harder conversation to have.
And we've seen exactly that. I think recently I saw a case where there was a container, it was a pretty big workload that had 4,000 millicores more than it needed. It had like 9,000 or something, and it only needed 5, but was replicated 250 times. So it was 1,000 CPUs of extra. And containers don't overcommit the same way a VMware environment does. If you ask for 9,000, millicores, that's given to you on a node, and the scheduler won't give away more than what's on the node. It doesn't give away the resources multiple times over. You can steal from each other at runtime, but when you're scheduling, you get what you asked for. So it's direct waste. And funny thing is, the people deploying those may not even see the bill because it's the scale group that gets big. You said that end up in a giant scale group with everybody else. It's really hard to see what's happening. But, the person deploying the container that's way too big doesn't even have any idea what it's costing them. It's completely downstream somewhere else. So to your point, that transparency on that, mapping it back is pretty important.
And one of the most, I guess, interesting things when it comes to mapping that cost back is I'm lucky enough to have had experience with a number of different companies and a number of different departments over my years, and seeing how different companies go about mapping that cost back. It'll range from buying multi-million-dollar tools to employing several very skilled Excel, for want of a better term, Excel engineers to build some amazing models. And there's no one right way to do this, but the only wrong way is to not try.
Mm-hmm. It's funny, like in the early days of any technology, you find that there's the kind of the gurus that are handcrafting solutions and being creative. And I almost view it that if creativity is required, that has to mature, because at some point there should be a way to do it. It shouldn't require creativity anymore, but we're still in an era of creativity around these things where, we work with a lot of different companies and you see some really clever things being done to solve these problems. Ultimately, ideally, the customers wouldn't be having to do that. Somebody would have solved that problem once and it's no longer a problem, but
exactly.
It still is.
One of the interesting things about moving to a different culture for me has been understanding how they approach software. So, for example, in Australia, there's a lot of emphasis on undifferentiated heavy lifting and not necessarily reinventing the wheel. Whereas in other cultures, there is a larger focus on building the tools and building the skills in-house. Mm-hmm. Far more of the focus goes towards that.
Yeah, that's an interesting observation. So do it yourself versus, build versus buy. You see that kind of different mentality, even across companies. Some companies used to work a lot in the banking world where some banks love to build their own stuff and some like to buy products. It's just kind of a cultural thing that varies. So
I used to work with a bank in Australia who would both buy and build at the same time. So they would effectively buy the application and then understand their workflow within the application and then do their best to replicate it on the side. And I always thought that was a really interesting way of handling that problem, especially around cost attribution, because it forced everyone to go quite in depth to understand their own costs, their own tagging strategies, and how and why different things work. So it's always a double-edged sword.
Mm-hmm. Now, as a vendor, I'm not sure I'm a big fan of that approach. Yeah, it does sound pretty efficient. We talked about cost optimization from a kind of the resources and right sizing and elasticity. And then the other side of it, we like to view it as it's kind of price times quantity. You can reduce the quantity, which is what we focus on and we've been talking about. And then there's the actual price. Maybe you can talk a bit about that in terms of always good to get the best discount. And then, of course, apply that to the lowest number of things. So what are your thoughts on the actual bill itself and the discounting?
So there's a couple of different ways you can look at this. Of course, you've got the rather touchy subject of EDPs. And so that mostly revolves around being a relatively large customer where you can demand discounts from your provider. And if you're simply looking to cut costs without any, I guess, hard engineering work, that would be the fastest, most low-hanging fruit. Mm-hmm. And then from there, and not to discount that, but that's where the real work begins. So once you've settled on the best possible price with your provider, you then need to focus on doing what you can with what you've got. And so a lot of times, one of the fastest ways to a successful FinOps project is uplifting the generations of, specifically focusing on AWS here, uplifting the generations of instances. So for example, moving from a M4 to an M5, you have, these are different AWS instance types. You have similar or lower prices, and you have more performance out of the CPU, higher frequency, higher clock speed on the RAM bus, higher clock speed on the CPU. And this is where you need to have a bit of an understanding of hardware within the cloud. And I know that is somewhat of a misnomer. We were sold the idea of cloud that you'd never have to actually think about hardware again. But in reality, you really do. You can get by without it, but you'll fall into these pitfalls. One of the easiest ways for us to show value is to move from older generations to newer generations, and then we can begin optimizing the actual workloads at that level. So for a container, that often looks like understanding it, ideally using a tool to help you understand it, and then pulling that data out, making a recommendation, and then working with the teams to bring that back in line with something that is based on real world usage rather than initial best guesses when deploying the application.
Mm-hmm. And it underscores the fact that, the cloud is changing all the time. So even the thing that was the best when you deployed it, it could be ancient as time goes on. So we use the phrase modernization. Say, let's get onto the R6Is or whatever the latest thing is. Yeah. It's amazing how many people don't do that. You articulate it well. Like, it's really only upside. But if you don't have time, it's just a matter of neglect. If you leave something on an M4 too long, it's probably just because you haven't looked at it. That's an area where it is a low-hanging fruit, where if you just use software to kind of constantly watch that, it's much better than neglecting it altogether.
Definitely. I do want to perhaps argue one point. It is low-hanging fruit to a certain point. One of the problems that can occur is at scale, it does not work to just say, all right, we're going to go to R6i, because depending on the region you're in, it can be possible to drain or deplete all of the cloud resources of that new instance type. And this is something that we haven't necessarily touched on, but if you are looking at going down this path of FinOps, one of the most important relationships you can build, other than with a vendor such as yourself, is with your cloud provider, so that you can work directly with them. And so if you want to make a move from R5 to, say, the R6i, you can let them know ahead of time and you can build a rollout plan with them. If you're talking about 10 or 15 instances, it's not too much of a problem. But when you're talking about thousands or tens of thousands of instances, you really need to work with that provider.
It kind of shatters that abstraction you alluded to that a minute ago, that's not the illusion of the cloud as being limitless. It's not. It's actually hardware sitting in racks.
Yes.
And the hardware does matter. And I find it interesting because We optimize Amazon and Azure and Google. And Google's interesting because they're a little bit different than the others. They do take the abstraction a little further in that you can have an instance type that you ask for, and underneath it, there can be a chip, like a CPU from 2014 or 2021, or it can be almost anything underneath it. It's kind of crazy when you think about that you don't know what you're getting underneath, but there is a way to ask for it. We did this analysis. You can request, the Ice Lake chip on that instance type, and you'll get a newer chip if it's available. So there's this kind of abstraction that we all bought into with the cloud. And then there's certain reasons why you can't take that too far, like there's not infinite supply. And there's also reasons why you might want to pierce the abstraction, because for no more cost, I can get a CPU that's years newer.
Yes.
Just by asking for it. A lot of people don't know that.
Amazon's in some level done a bit of a disservice by abstracting this so much. It does work great at small and medium scales, but once you start getting really big, you do have to pull back the covers a lot. I'm not familiar with GCP, but I can imagine that if you needed, say, certain AVX extensions, you could find yourself in a bit of hot water if you built your application, it was running fine on a particular chipset, and then you launched onto a different chipset that was missing those extensions, unless they're emulated, in which case you've got emulation issues. Mm-hmm. You could find that something doesn't work quite right.
Yeah, it's a very good point. And we partner with Intel quite a lot, and we do a lot of work on, detecting the application that's running and recommending something that has an accelerator for that application. Mm-hmm. To your point, like an AVX or a Quick Assist or Crypto NI. And it really does make a huge difference to the performance, but you kind of have to know what chips are underneath the instance type. So actually, I think Amazon does a pretty good job of that, of being clean about the R6i, what chip is under it, or the new R7IZ. Like, what's kind of under that. Whereas, in Google, you can ask for it. So there's a way to make sure you're getting it. But if you don't, it could be almost anything. And to your point, it could put your app offside if you're leveraging that. And then all of a sudden you restart and you're not on the same CPU anymore. But it is a very good reason to kind of, again, pierce that abstraction, because there are clear benefits to be had to the software running, depending on what's running underneath it. You can't make that abstraction too harshly, or you will lose a lot of performance.
Yeah, it really depends at what scale, what you're actually doing. For a long time, we often thought about cloud as a one-size-fits-all product. But as the cloud industry has developed and as everyone has developed with it, I'm starting to see a lot more interesting things being done in cloud. And I remember when I first started, there was a lot of this hybrid cloud mentality. And then we very quickly shifted to seeing a lot of companies being cloud only. But recently, with the advent of generative AI, I'm seeing a lot more companies moving effectively back towards a hybrid cloud model where we're having GPU-based workloads running on-prem. A number of my friends and colleagues are working in businesses where they are now, for the first time in many years, actually deploying racks, physically racking and stacking servers so that they can have generative AI. Because at the moment, the price and availability of GPU in the cloud is not exactly static. And if you're doing really large workloads, at times it can be worthwhile to have those workloads run back on-prem.
There's probably a couple of aspects to that when you think about it. There's probably guaranteeing your supply, because, again, back to the point, who knows how many GPUs are actually deployed in that region in the cloud. And I've heard a lot about, the security of the data that you're training off. I think that's probably a big fear for people, that they might want to train on a data set that they don't want to put in the cloud. That could be driving some on-prem behavior as well in the AI world. It's a fascinating area.
The security of the data. If you thought about 100 years ago, some of the most complicated technology were Swiss watches, and the manufacturing processes for those, the designs, they were kept really as closely guarded secrets. Effectively, these days, not a lot has changed. When it comes to things like generative AI or a lot of these new technologies that we're seeing, the company's true asset is its data. Not necessarily the end product AI, but the steps used and the data used to build those models. That's truly where effectively the keys to the kingdom are, that's what's becoming more and more the closest guarded secrets.
The training program to make everybody smart. That's the most important thing.
Yes.
It's such a fascinating area. It's playing out so fast, like so quickly, what's happening in that world.
I'm spending a lot of my personal time just trying to keep up. It's fascinating how fast it's moving.
The quote I love, technology, when sufficiently advanced, is indistinguishable from magic.
Yes.
I love repeating that because AI is truly that. Like, it's true. And with AI, it's really true. Like when you ask it to generate a picture of whatever, somebody doing something, or it's amazing that it can do that. It's just mind boggling.
As you mentioned, Asimov said, it's indistinguishable from magic.
Yep, it is. There's something I wanted to get your thoughts on, and that's serverless. So, I mean, again, it's another really cool abstraction that now you don't even really care what's under it. You don't know what's under it. Do you use serverless a lot? Do you have any strong thoughts on it? Is it the future? Is it just kind of semi-useful?
It's the future, it's the past, and it's a flash in the pan. The reason why I say that is I've been wrong many times, and I'm sure I'll continue to be very wrong about many technologies. I mean, every year is the year of the Linux desktop. I liken that a lot to, for example, serverless. There are some serverless technologies that are great, but when it comes down to is serverless, it still runs on a server. There is still actually a physical chunk of iron underneath this running this code. It's containers without containers. If you extrapolate out the idea of containers, serverless was the next logical step. I think that for some workloads, it's absolutely fantastic. And there is a lot of legacy workloads that I myself have, and I've seen from coworkers, friends, colleagues, successfully move legacy applications to things like serverless, to Lambda functions specifically. And that's absolutely fantastic for 2 to 4 years. And then that person doesn't work there anymore. They've moved on to a different team, onto a different project. And you realize that serverless app was written in Python 2.7, for example. And then it needs to be updated because AWS says that code's too old. You can't run Python 2. For you to relaunch this Lambda, you need to rewrite it in a new version of Python. Now, at some companies, oftentimes that is simply forgotten. And again, this is where having a strong relationship with your cloud provider is really helpful. They can reach out to you and let you know, like, you have a certain amount of serverless workloads that are now running on legacy code bases that cannot be relaunched. So I think in a lot of times people see things like serverless as a one and done, set and forget. You write it, you run it for the rest of your life. It's not. All of these applications, they are effectively living organisms that do need some maintenance, some TLC. And if you don't take care of them, you will one day wake up to being paged because a critical Lambda function that was shuffling data from A to B has now stopped working.
That's a fascinating perspective. I never really thought of it that way. It's almost back to like computer science 101 from decades ago, where like maintainability, like, make sure the code is commented and make sure people understand what it's doing. And because I almost find like serverless and even containers to a certain degree are like turning an app inside out. Like, you used to write a monolithic app and inside it would be a thread pool and there would be some kind of storage and all these things. And now you can explode that out into many components that are all distributed and launched separately. Containers are a great example of that. So now you've constructed the app out of a bunch of loosely coupled things that you're almost talking about like a fragility. There's a fragility to it where what it's doing and then moving it forward becomes a completely different ballgame when it's exploded apart like that. When you talk about it, it reminded me of, again, I think it was back to the mainframe days and COBOL or something where it would become unmaintainable.
Yes.
As it aged. We're just repeating ourselves over and over here, but with newer acronyms.
My old mentor politely reminded me that there's absolutely nothing new under the sun. Containers were effectively C groups on Linux not that long ago. As you mentioned, back to the mainframe era, I'm very lucky that I had a lot of experience with mainframes. I went from a Linux engineer to a mainframe sysadmin, which is not generally the career path that most people would take. And I'm very thankful for that because it really does give you the sense of where all of this came from and where we're effectively wrapping around back to.
It's really cool. I don't think we like to think of it that way because it makes it seem less elegant what we're doing. But VMs, all these things, they all map back to that. So, I think it's all moving forward in very interesting ways. But in many ways, some things never change, and the problems that we see popping up, they just keep recurring in the new technology, whatever it is we're using now.
I think part of that is because, especially in the old Unix days, where we were so limited on things like CPU, disk, and memory, optimization had to come first. Otherwise, you simply couldn't launch the application. Those routes did continue forwards. And so that's why I think we see a lot of this wraparound is through the early 2000s and the 2010s, we saw effectively an exponential growth of availability of things like RAM, bandwidth, disk bandwidth, and CPU clock. And now we're sort of coming back to this idea of maybe we shouldn't be throwing memory at an application. Maybe we shouldn't be throwing CPU. And I think that's where we're seeing a lot of these hallmarks of the previous generation of computing around mainframes, where we were space constrained, where we were resource constrained. And so that's why it has a lot of similarities to those older methodologies, effectively because we have come full circle.
When things are completely unconstrained, then you get sloppy and discipline goes down. Even going from machine code to like BASIC or to other languages way back, the elegance is lost. You start bloating more and more, and
it's not necessarily that bloat is bad or malicious. It's really driven, I think, mostly by people's enthusiasm and excitement for the next thing, for developing what's big next. And if you can cut down the amount of time required for someone to learn how to develop an application by doing things like not writing in machine code, not writing in assembly, and move to things like, for example, Python, it's much quicker for people to churn things out, which oftentimes is more economically viable and therefore effectively, perhaps this is a bit too preachy, but it's better for society that people can churn things out faster. But we always do have to think about the unintended consequences. And oftentimes that comes in the form of a cloud bill that is rather unexpected.
It's funny because when you put it that way, I guess it really underscores the fact that the most precious resource out there isn't CPU or RAM or network. It's people time.
Exactly.
If you can get people to do stuff, because people are scarce, and that's one of the biggest problems in the progression of our industry. If people can be more productive as a result, you have to deploy more resources. Well, maybe that's a fair trade. Now, there's a fine line though, because I would argue that some things become so inefficient, the cost really starts to outweigh the productivity of getting out there. So it's all that balance: performance, cost, people's time, cost. But how far do you go? Because maybe you don't optimize cost to the nth degree. You only go so far because it's diminishing returns on that.
Exactly. The most important resource is people's time. And be that engineers, program managers, executives, whoever, it's really expensive to go to these people with poor quality recommendations. And again, this comes full circle back to the idea of your recommendations are only as good as your tags. Your recommendations are only as good as your weakest data source. And so if you don't have the tooling available to dot your I's and cross your T's when it comes to the quality of your recommendations, at best, you're wasting people's time.
Which is probably one of the worst things you could be doing. It's been a great conversation. We've covered a lot of areas, optimization and cost and kind of the way things have progressed. Any, I guess before we sign off, any last parting thoughts on things? If you were to tell people what's the one thing that you think is the most important out there from all your experience in this area, what would that be?
The most important things is, as always, stay curious. But when you talk about the idea of what's most important in FinOps is cloud cost optimization. It's around building a culture of continuous improvement and continuous optimization. The road to $1 million worth of savings, it's paved with a lot of $1 coins. Oftentimes, the way for you to build this culture is to make small recommendations. And if you can bake these recommendations into a pipeline, even better. For example, if you create a culture where you regularly meet with teams, you regularly meet with stakeholders, and you are able to show, if we make this small change here, yes, we save $10 per container, but we have 1,000 containers. Our end goal is to move to a container of, say, X size, but today we're only going to move 10% of the way there. And then next month, when we redeploy our applications again, we're going to shrink that again by 10%, 10%, 10%. It's all about finding the lower hanging fruit, demonstrating to people that you are actually able to make small optimizations along the way, and that you are able to deliver on these promises.
Build in, continuously do it, and the little wins can be the big wins if they're happening all the time. So Luke, with that, I think we can wrap it up. I was hoping we could give everybody a link to your sandwich reviews that you worked on during the pandemic, but it sounds like that's not available on the internet anymore. So we'll have to get that back up, because I think we all want to see all these weird and wonderful Korean sandwiches from convenience stores.
I'll have to rehost my blog on, perhaps not on a Raspberry Pi this time.
Seriously, bring it back. I would love to read that. It's been great talking to you. Thanks for taking the time today from halfway around the world for me anyway. I think your sun's up now. My sun's going down. So it's probably a good time to sign off. But thanks again for joining us today.
Andrew, again, thank you. It's been an absolute pleasure chatting to you today.
Andrew Hillier and Luke Travers, thank you both so much for an awesome episode full of excellent content. And once again, my name is Brian, producer of Densify Talks. Thank you so much for listening. Appreciate it. Thanks for joining us. We have so many more incredible episodes coming your way. Lots of great content, so make sure to subscribe to the show so that you do not miss any episodes whatsoever. And by the way, we would love to hear from you. Densify.com. You can also send any questions that you have, and if you'd like to be on the show, email us, marketing@densify.com. Have a glorious day. We'll talk to you in the next episode, and I think we're going to be signing off. Have a great day.